Welcome to Get Your FRQ On. This question is from 2014. It's question 1, and it is calculator active. In the question stem, we're given grass clippings in a bag and a function that models the amount of grass clippings in that bag. In part A of the question, we are asked to find the average rate of change of the function a of t on the interval from 0 to 30, and to provide units. So we're given the function a of t to use. It's not very pleasant. We could maybe find the derivative of this individually or evaluate. You're not going to evaluate this at 0 to 30. You're just not. It's a calculator active question. We do need to use the right formula here. The formula for average rate of change would be a of 30 minus a of 0 over 30 minus 0. But you're going to use your calculator to get those values. You're just not going to do this by hand. So use your calculator. The average rate of change of a of t on the interval from 0 to 30 is negative 0.197 pounds per day. In part B of the question, we are asked to evaluate the derivative of a of t at t equals 15 to provide the units and meaning in the context of the problem. So again, we're going to use our calculator to do this to find the derivative here at 15. I suppose you wouldn't have to, but it's a calculator active, so you might as well. So it turns out a prime of 15 is negative 0.164. Okay, well, what does that mean in terms of the problem? Well, what it means is that at t equals 15 days, the amount of grass clippings in the bag is decreasing at a rate of 0.164 pounds per day. Now, be careful when you explain things like this. There's two sort of trains of thought on this. One is to just declare everything is increasing and then use the value of the derivative as the rate. The other one is if it's increasing, say it's increasing. If it's decreasing, say it's decreasing. And then always use the magnitude of the rate. So I've used decreasing here, but notice I've used a positive value for the rate of change here, or the derivative. So that's decreasing at this rate, which would be one of the two correct ways to state it. In part C of the question, we're asked to find the value of t such that the amount of clippings in the bin is equal to the average value of the clippings in the bin over the interval from 0 to 30. So the first thing we're going to want to do is we're going to find the average value of the clippings in the bin by using the formula for the average value of a function. Right, in this case, we're going to take 1/30th of the integral from 0 to 30 of a of t dt. Again, it's a calculator active question. Use your calculator to find this value. It turns out it's 2.753. Right, but now we need to figure out what value of t has the property that that's how many pounds of clippings are in the bag at that time. And again, it's a calculator active question. There's a lot of different ways to do this on a calculator, but the value of t we need is 12.415. In part D of the question, we have a linear approximation function to model the data for t greater than 30, and we are to use it to predict when there will be a half pound of clippings in the bin. All right, well, a of 30 is 0.783, and a prime of 30 is negative 0.056, which means we can write the equation of this linear approximation function. L of t is negative 0.056 times t minus 30 minus 0.783. All right, now we want to figure out the value of t for which this is equal to a half, so we want to set L of t equal to 0.5, or use the fraction a half, it's not going to matter. And then solve the equation for t. Again, it's calculator active. You're just going to use your calculator to do these arithmetic steps anyway, and we get a value of t 35.054 days. All right, that's it for this question. Don't forget to like and subscribe if you want more AP Calculus free response solutions. You can go to my YouTube channel and subscribe at youtube.com/@GetYourFRQOn, or you can follow me on X or Twitter at GetYourFRQOn there as well.